Hello, boys and girls. Today we will be working on a fractions performance task together. As you look at the picture that is shown, it looks like a clothing store. Well, our performance task has something to do with a clothing store. So let's begin. What are performance tasks? A performance task is a huge task at the end of learning several concepts. The task allows you to use the skills you have learned to perform many tasks that build from one another. They usually involve a scenario or a situation with a problem that you must solve. The tasks may go from simple to complex, which is not as simple. They may involve using charts or information from previous questions that are answered. So this performance task is actually in your packet, and it's for topic 13, and it's our fractions performance task. And as you can see, it has to do with a clothing store. So it says, Devin, Jenna, Eli, and Gabby work at a clothing store. On Saturday, they each worked the same number of hours. As you notice on the right here is a chart. So it says the time spent at the cash register table shows the fraction of time each person spent checking out customers. The time spent on customer calls table, which is on another page, shows the fraction of an hour that Jenna spent answering phone calls for the store. We're going to use the time spent at the cash register table, which is this table right here on my right, to answer questions 1 through 3. So number 1 says, draw fraction strips to show the fraction of time each person worked at the cash register. Now you notice they gave us a little hint that with this one whole strip, because this one whole strip represents something very important. And that one whole strip represents a whole work day. So if you look on the chart, and it gives each worker's fraction of the workday that they had worked at the cash register. And you notice that all the fractions have something in common. Can anyone take a guess? If you saw that every one of these fractions has 6 as the denominator, you are actually correct. What does this 6 really mean? Well, previously we stated that they were working hours in their workday. So this 6 that you see at the denominator represents the number of hours that equals a workday. So Devin worked 3/6 of her workday at the cash register. So to say that in a different way, that means she worked 3 hours out of 6 hours at the cash register. So if we wanted to draw a fraction strip to show how much time that Devin spent at the cash register, we would first draw a fraction strip. Make sure that it's exactly the same size as our one whole. And then we are going to partition it into 6 equal pieces to represent the 6 hours. Again, Devin worked 3 out of those 6 hours. So we are going to represent 3/6 by shading in 3 parts out of the whole. If we look at Jenna, Jenna also worked 6 hours. And so we're going to draw her strip. And we're going to partition it into 6 equal parts. So let's take your pencils and go ahead and split that strip into 6 equal parts. Okay, you should have 6 equal parts. And again, she worked 2 hours out of those 6. So we're going to only focus on 2 parts, and you're going to go ahead and shade in those 2 parts to make 2/6. Now, we're going to go ahead and draw Eli's strip. So right underneath Jenna, you're going to draw another strip. Make sure it's pretty much the same size as the other 3 strips. And again, he also works 6 hours. He has 6 hours of his workday. So we're going to partition his strip into 6 parts of the whole. But Eli worked 6/6 of his workday he spent at the cash register. So what would that look like? How many pieces would we shade in for 6/6? Go ahead and shade those pieces in. If you shaded in all of the pieces, you are absolutely correct, and that would represent 6/6. And last but not least, Gabby. Gabby spent 5/6 of her workday at the working at the cash register. So again, we're going to draw a strip for Gabby. And just like the others, her workday is 6 hours in total. So we're going to go ahead and partition Gabby's strip into 6 pieces. So now let's look at her fraction. How many parts again of her day, her workday, did she spend at the cash register? Go ahead and shade in that amount. If you shaded in 5 out of 6 parts of her strip, then you were absolutely correct, and that shows 5/6. So now their strips are completed. So now number 2 asks the question, who spent the most time at the cash register? So remember all of the work that we did in the previous question. And we still are looking at our table. Who spent the most time? So I would be looking at the person who has spent the greatest amount of time, the most amount of time out of the whole 6 hours or the whole. So which one would that be? If you look at the strips, you will note that Eli spent the most time at the cash register because in comparison to all of the other workers, he spent 6/6 of his workday, meaning his whole workday, at the cash register. So he spent the most time. Okay, so number 3, it says write a comparison to show the time Gabby spent at the cash register compared to the time Devin spent. And we need to use our symbols, our comparing symbols, greater than, less than, or equal. All right, well, we already have the 2 fractions here. So we noticed that from our chart that Gabby worked 5/6 of her day at the cash register, and Devin worked 3/6 of her day at the cash register. All right. Now, if we wanted to go back and take a look at our previous work that we completed compared to Gabby and Devin, which one spent the most time or worked the most time at the cash register? So we're comparing 5/6 and 3/6. Okay. So if you thought that Gabby spent more time, we can use our greater than symbol to say that 5/6, which was Gabby's time, is greater than 3/6, which is Devin's time. Okay, so now we have a different chart, and this chart is the time spent on customer calls. So it says use the time spent on customer calls table to answer the question. On which day did Jenna spend closest to an hour on the phone? Explain how you know. So there's two parts. So let's kind of look at each of the fractions of an hour, okay? Because remember, we're dealing with an hour, not a whole workday. We're just worrying about how much of her hour did she spend on customer calls. So again, we're going to use our one whole as our benchmark to represent our 1 hour, our whole. Okay. So for Saturday, it says she worked or she spent 3/6 of an hour on customer calls. So if I drew a strip that was in similar size to our whole, then I would have to represent 3/6 partition this strip into 6 equal parts. Okay. So I'm looking at the numerator, and the numerator says, 3 parts of that hour, whole hour, which was 6 parts, she worked or she spent taking customer calls. So this is what 3/6 would look like. Okay. And if you were really looking in comparison to this whole strip, we could also say that she spent a half an hour, half of the hour, taking customer calls. If you wanted to look at it another way, because we know that 3/6 is equivalent to 1/2. All right, so now let's look at on Sunday. So again, we're still trying to look at or represent a fraction of an hour. So on Sunday, her hour looked a little bit different. It was divided into 5 parts of her hour. So we had to partition her strip into 5 parts. Now, we do not necessarily, most of the time, we don't work with fifths a lot, but we're going to try our best to divide the strip into 5 equal parts. Okay. All right. And sometimes when you draw them in, you might have to kind of eyeball it a little bit and you might have to erase it, but just try to get it as close as possible. So if you look at this fraction, we notice, both fractions have the same numerator, but the denominators are different. So we know that we're dealing with 3 out of 5 parts of the hour that she spent on Sunday taking customer calls. And now let's look at Monday. Again, we see that Monday is 3/4 and has the same numerator as the 3/6 on Saturday and the 3/5 on Sunday, just a different denominator. So let's draw our Monday strip. How many parts are going to be partitioned in this strip? Go ahead and partition your strip. This is 4th, so it should be a little bit easier. So we will split it up into 4 equal parts. And again, 3 out of those parts, 4 parts, she spent on customer calls to represent 3/4. So let's go back to our question. The question asks, on which day did Jenna spend closest to an hour on the phone? So we know that if we use our one whole strip as our way to, as a benchmark way, we know that this is one whole. So if this was like on a number line, we know that we would start here at the beginning, but right here at the end is one whole. Okay, so that means we're looking for which of these fractions would be the closest to that one whole, or that 1 hour. So let's see. If we look, it's almost kind of like a race. Which one is closest to the finish line? Which one do you guys think? Which day? Saturday, Sunday, or Monday? Well, if you notice that the Monday strip of 3/4 is a lot closer to the whole than 3/6 and 3/5. So Monday, she spends the closest to an hour on the phone. Okay, so let's go ahead. Oops. So Jenna spent the closest to an hour on the phone on Monday. If you look at my model, it shows that 3/4 is closer to one whole than 3/6 and 3/5. Now remember, we talked about how the numerators were the same the whole time. They were the same, but the lower the denominator means that the whole was broken into less pieces, which means those pieces were the bigger pieces. And that is why the Monday pieces, or the Monday fraction, was closest to the whole, or the 1 hour. Okay, so it says the store sells different colors of men's socks. The socks table, which is over here to my right, shows the fraction for each sock color in the store. Use the socks table to answer questions 5 and 6. So here's part A. It says complete the fractions on the number line. Label the fractions that represent each sock color. All right, so let's kind of look at what we have here. So first off, let's look at our number line. We know that this number line represents a whole because it starts again at 0 and ends with 1 at the very end. What else do we notice about this number line? How many parts is this number line partitioned into? Okay, so let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 equal parts. So we know that we're going to split, or our fractions are going to be represented with eighths. Okay, so let's look at our first fraction. We have white socks, and our first fraction is 1/8. 1/8. So 1/8 would be found right there. Okay, I'm going to skip this one for a minute because I want to come back to that one, but let's look at the brown, because again, we're dealing with eighths. So I'm going to go ahead and put the fractions already with eighths on this number line. So we have the brown sock, which is 3/8, and the gray sock, which is 2/8. So we're going to put those on. Okay. Now let's finish these up. So if we know this is 1/8, this is 2/8, this is 3/8, the next would be what? be 4/8. Then that means the next one would be 5/8. Oops, sorry. The next one would be 6/8. The next one would be 7/8. What will we name the one that is marked 1 whole? Go ahead and jot it down on your paper. After 7/8, it would be 8/8. Okay. All right, so now we see right above, there are some boxes here. I wonder why these boxes are here. They look like they're representing fractions that might be equivalent to the ones that are right below on our number line that is representing the eighths. Well, remember, we still have the black sock, which is 1/4. So where would 1/4 go? Well, let's see. First off, let's make it easy for ourselves. If we're going to place fractions, other fractions, we're going to come up with another number line. So we're going to draw another number line here so it will keep us straight. Where would 1/4 go? So now I'm looking at this as same number line, but now this number line is partitioned into 1, 2, 3, 4 pieces. So 1/4 would go right here. And after 1/4, what will come after that? Go ahead and jot it down. Well, I remember that 2/4 will come after 1/4. And then we will place 3/4 after 2/4. And what would represent our whole? If you said 4/4, you were correct. All right, so we labeled our fractions that represented each color. Everything has been plotted on our number line. So now we're ready for part B. It says, does the store have more brown socks or more white socks? So if we look at brown socks, which is 3/8, and we look at the white socks, which is 1/8, we know that the store has more brown socks because 3/8 is greater than 1/8. Now, we need to still use the same number line that we used in the previous page to construct an argument. That sounds really deep. To justify the following conjecture or the following statement. The store has an equal amount of gray socks and black socks. Okay, so now we need to go ahead and fill in our chart again. So we had this as 2/4, 3/4, 4/4, 4/8, I'm sorry, 5/8, 6/8, 7/8. Okay. So again, with our question, there's a statement that was made. It says the store has an equal amount of gray socks and black socks. So on our chart, we know that 1/4 of the socks were black. And then we know that 2/8 of the socks were gray. So let's find both of those fractions. So I'm going to find our 1/4 black, which is right here. Remember, we split this number line into 4 pieces or parts. And then we have 2/8 right underneath it. Are these two fractions equal? Are these the same? Is the statement the store has an equal amount of gray socks and black socks correct? Okay, because when I look at these two fractions, they look like they are at the same spot on the number line, on each number line as part of the whole. So let's see if we are correct. So it says the store has an equal amount of gray and black socks, just like we said. One way that I know is that when I look at the point on the number line for 1/4, which we started with, and the point for 2/8, they're in the same location on the number lines. I can line them up. You can see how they're lined up to see that they are equivalent fractions because they line right up to one another right there. They're at the same point on that number line. So right here. Okay. Number 7, use the Miguel socks table to answer the question. Miguel bought some socks at the clothing store. After he washed them, he counted the number of individual socks he has. Each sock is 1/2 of a pair. How many pairs of black socks does he have? Write this number as a fraction. All right, so on our chart, we noticed that he has 6 socks. Black socks, excuse me. And he has 8 gray socks. We know that socks come in pairs, and they said he had 6. So this is a pair, that would be 2. That's another pair, that would be 4. And that's another pair, that would be 6. But remember, each sock is considered half of a pair. So how many pairs does he have? Okay, so we count our pairs as 1, 2, 3. But now they say we have to write the number as a fraction, meaning the number of socks he has as a fraction. So remember, we said that every sock was equal to a half, 1/2. So this is 1/2. This sock is 1/2. The sock is 1/2. The sock is 1/2. This one is 1/2. And this one's 1/2. How can we make a fraction? So if we look, we have split our pairs into halves. How many halves do we have? We know we have 3 pairs, but how many halves do we have? I didn't count them. So we have 1, 2, 3, 4, 5, 6. So the numerator will be 6. And our denominator, because we split them into halves, would be 2. So there are 3 pairs, as we stated, and the fraction is 6 halves because each sock represented a half of a pair. And because we split this into halves, we have 6 halves. Remember, now we're getting into fractions greater than 1 whole. So we have 3 wholes or 3 whole pairs, and they were split into halves. So that if we wanted to look at it in another way, so there's a number line here. So from 0 to 1 is 1/2. That represents 1 sock. And this also represents another half. So that's 2 halves that equal 1 whole. That's just for 1 pair. So if we have 1 whole, what would this represent? Well, now this will represent 2, our 2 pairs. And each sock, again, equals a half. So then this is 2 wholes. Oops, 2 halves, I'm sorry. Then this would be 3 halves. What do you think 2 wholes would be? 2 wholes would represent 4 halves. Kind of hard to write here. Okay, but that's just for 2 pairs. So now we need to extend our number line. So we have 2 whole pairs. Now we have 3 whole pairs. So then what would be between here? So we have 4 halves. This would be 5 halves. And then the 3 would represent 6 halves. And that is another way of looking at 6/2 on a number line. And boys and girls, I believe that that is our last question. I hope you enjoyed working through the tasks of this performance task.